What's up, everyone? Happy Tuesday. Miss Burke is back for some notes. We are going to jump right in. Basically, we are proving again, but we are focusing on parallel lines and not our angle relations, okay? But we'll see how they're somewhat connected here in a moment, okay? So, first thing we have to do is talk about what a converse is, okay? And I'm not talking the shoe, even though they're cute. All right, we have to remember that the converse is when we're given a conditional statement, if P, then Q, where P is our hypothesis and Q is our conclusion. This is a conditional statement. This is not the converse. This is just a good old-fashioned conditional statement. If something happens, then something else will happen. The converse takes that order, hypothesis, conclusion, and it flips it. So it swaps the order of the hypothesis and the conclusion. So now, instead of if P then Q, it's going to be if Q then P. Okay, so we're going to write the converse of the following statement. If two lines are perpendicular, then they intersect to form right angles. Okay, so let's write this converse. If, and so we're now looking at the purple portion, the old conclusion becomes our new hypothesis. Let's just say if right angles are formed by an intersection, and this is where it gets kind of tricky to reword it perfectly, then those two lines are perpendicular. Now, we could have probably written this a little bit better, but it is currently 8:38 and my brain's a little fried from the day. So, possibly we could have said, if two lines intersect to form right angles, then they are perpendicular. That sounds much better, but it works as long as we are writing the same thing in a different way, flipping the conclusion and hypothesis, we are golden, okay? So, the next question asks, are converse of true statements always true? Meaning, if I gave you a true conditional statement, is the converse always going to be true? Now, let's say no. And let's see if we can come up with an example. Okay, so conditional statement could be if you, if you here we go. Sorry. Once again, like I said, brain's fried. If you teach at Hilliard Darby High School, then you are employed by Hilliard City School District. Okay? Just thinking of myself. Now, what about the converse? The converse would state, if you are employed by Hilliard City School District, then you teach at Hilliard Darby. Well, we know that's not true, okay? So, hang on. We're just going to refocus back up to this conditional statement. It says, is the conditional statement true? Meaning, if two lines are perpendicular, then they intersect to form right angles. Yes, I would have to agree. All right? Knowing that lines are perpendicular, I know that they intersect to form a right angle. Okay, is the converse true? If two angles formed by an intersection, or if two lines form right angles when they intersect, then they are perpendicular. I would also have to agree. Yes, true. Oh, it says, is it true or false? True. Okay. Now, we've got quite a bit of definitions to remember, okay? But they're all pretty much kind of the same, just slightly different, okay? So, corresponding angles. Converse. Basically, we're taking our corresponding angle postulate and we are flopping it, okay? So, if two lines are cut by a transversal in a pair of corresponding angles are congruent, then the lines are parallel, okay? So, say I've got some lines that, just slightly look a little bit not parallel, okay? And then I've got this transversal. Those two lines were cut by my transversal, okay? If I know, we'll use a better color. If I know that these corresponding angles are congruent, then that is enough to tell me that these lines are parallel, okay? Opposite of that, we have consecutive interior angles converse. If two lines are cut by a transversal in a pair of consecutive interior angles, are supplementary, okay, then I know that they are parallel lines, okay? So, same thing. I've got some lines that, we're trying to prove are parallel. Well, I can prove they're parallel as long as I know that this angle here and this angle add to be 180. If I know that for sure, I know that they're parallel, okay? Now, this is where it's different. So before we worked from parallel lines to stating the angle theorems. Now we're told that we have that angle theorem, therefore we know they're congruent or parallel lines. All right, you can probably guess how the rest of these are going to go. If two lines are cut by a transversal in a pair of alternate interior angles are congruent, then the lines are, yep, you guessed it, parallel. Okay? They look a little bit off, but I'm not going to judge them. We're all a little off sometimes. All right, I've got some alternate interior angles. I know they're congruent, therefore I can state these lines are parallel. Okay, next one, alternate interior angles. I've got two of the same thing. Wow, Miss Burke, not doing the hottest. There is no difference. I'm just a dum-dum. Okay, you all know that. I couldn't spell substitution today. Well, when you're watching this yesterday. You can judge me forever. I deserve it. Okay, I think I just wanted the rainbow. Whatever. Anyway. Alternate exterior angles. If two lines are cut by transversal in a pair of alternate exterior angles are congruent, then the lines are, of course, parallel. And just to kind of hit home all of these angle pairs, remember we're looking for alternate exterior angles. If I know they're congruent, I know these lines are parallel. Okay? So basically, we can really just kind of look at the process as if I see that these are congruent, then I can write these wonderful arrows stating the parallel lines. Okay? So, we kind of already discussed, all right, these theorems are different because instead of going from parallel to angle pair relation, we are now going from angle pair to parallel. So I wouldn't say they're different, they're just reordered, okay? Like the converse. So we're good. All right? So if I have something like if M is congruent to N, then angle 1 is congruent to angle 8. Vice versa, we flip it. If angle 1 is congruent to angle 8, then I know that M and N are parallel. Okay? So let's look at some examples. Number 1, I've got that the angle here is 118 and the angle here is 116. Now, those look like some corresponding angles to me. But the measure, oh crap, these don't have measurements on it. Which is kind of annoying. But let's just state, well, 116 degrees is not equal to 118 degrees. Therefore, no, not parallel. All right. Now let's look at these guys. I've got that this guy is 71 degrees and this guy is 109 degrees. Okay, well that's not an angle pair. We don't have anything for consecutive exterior angles. We don't know anything about those. All right, but I could maybe think, well, do I know what this guy is? Based off the fact that this other angle that would potentially form a linear pair is 109 degrees. Well, if I wanted to find this other angle, I would subtract 109 from 180 and get 71. Okay, so let's take a look now. I've got 71 degrees, 71 degrees. They are alternate exterior angles that are indeed congruent. So, yes, they are parallel. Okay? Now, what has to be true about this guy and this guy in order to state that L and M are parallel? Well, considering their consecutive interior angles, I'm looking for supplementary, meaning that they add to 180. Okay, so let's just check it. I'm sure we're all smart enough to see, but let's just check it. That is 197 degrees, which is not equal to 180 degrees, so no. Not parallel. Alrighty? Cool. And just make sure that if it is parallel, we just practice putting those arrows in. Okay? Like I did right here. I just put those guys in knowing that it's parallel. Okay, now we've got kind of like a little puzzle. Alright? So it says in the diagram to the right, which lines must be parallel if the measure of angle 3 plus the measure of angle 6 equals 180. Okay, so let's look. These two angles right here, let's go like this, have to add to 180. Now, it's asking me, based off this, okay, what two lines have to be parallel? So, knowing that they add to 180 means we have to use the consecutive interior angle theorem. So, I need to find where to draw my parallel lines and transversal in order for these to be consecutive interior angles. So, I'm going to look at this guy and this guy to be my lines, to whereas this guy is my transversal. Okay, do we see how we now have consecutive interior angles? All right, so let's just go ahead, whoops, and state that line, let's say CB. We could say CA, but I'm just going to use that little piece. CB is parallel to line DE, okay? Next up, we've got which lines must be parallel if the measure of angle 6 is congruent to the measure of angle 9. Okay, now, this is where it gets a little weird because, all right, we don't have ones that look exactly parallel, all right? A little piece is missing to make it look a little wonky. So I'm going to just assume, based off congruency, that we're going to use some kind of alternate or corresponding. Based on their orientation, I'm guessing they're not corresponding, so I'm going to assume alternate. In blue, I drew my transversal. In red, I'm going to draw where I believe those lines would be parallel. Okay? So I'm going to state that line BD, okay, I'm taking the first point and the second point of that line, is parallel to line C. And I'm going to use this whole line F, or we could even state EF. Same line, multiple ways to name it. You can choose. Okay? Last one. Which lines must be parallel if the measure of angle 9 is congruent to the measure of angle 4? Ooh, those look like corresponding angles. All right, so we really have a couple options. Okay, so let's look. I'm going to go ahead and just draw these guys in. Oh, I guess we technically don't have a couple options. All right. Let's focus on these guys. Because we really only want to go for one transversal. I was thinking of two. All right, so there are my parallel lines, and I'm drawing in this transversal here. What that transversal did was it created this angle here that is up and to the right, and it created this angle here that is also up and to the right, meaning they are corresponding angles. Whoops, we didn't write alternate exterior angles, my bad, or alternate interior angles, corresponding angles, and I'm going to state that the line CA, I'm going to use the whole thing, is parallel to the line DE. Okay? Wonderful. Okay. Now, it states that we have a parallel transitivity theorem, okay, in a plane. If two lines are parallel to the same line, then the two lines are blank. Okay, well, let's just think. I've got my plane in which these lines are existing on. All right, we're going to just assume our lines are existing on that plane. I'm not going to draw it. And I know that M is parallel to N. But I also know that P is parallel to N. Okay? So, wouldn't it make absolutely so much sense if P were parallel to N, if M were parallel to N, okay, that M would also be parallel to P, okay? If we're having trouble seeing this, let's think about like them in an algebraic sense, okay? Parallel lines just mean they have the same slopes. They're increasing or decreasing at the same rate. So, if I've got two lines that are increasing at the same rate, and then another line that's increasing at that same rate, okay, then all three lines are going up at the same rate, okay? So therefore, all three lines are going to be parallel, okay? So, what I want all of you to do is work on some proofs using the knowledge in which we've gained today. Really, we're just now working in the opposite direction as we did yesterday. All right, and we have a brand new theorem that we can insert, okay? So, we are basically going to prove the transitivity theorem, okay? And so we know we have the first reason, always given. I'm going to go ahead and just write my last statement, okay? Always remember that what we're trying to prove should be our last statement, okay? So, let's think, and I'm just going to kind of coach us through these. What would we use to state that we know that angle 1 is congruent to angle 2? Then, what would we use to state that angle 2 was congruent to angle 3? Okay? And then knowing, ladies and gents, that those are all congruent to each other, we could maybe write that angle 1 could potentially be congruent to angle 3. And knowing that they're congruent, we could state that they're parallel. Okay, so hopefully that helps you there. Here, I just am trying to go from given to what I'm trying to prove in 2 steps. Okay, you've got 2 steps in order to do this. Okay, we have to state how we know these are congruent. Because we know they're congruent, we can state that they're parallel. Easy as that, guys. All right? So I'm going to let you kind of work through the last 2 on your own. Message me if you have questions. Thank you for tuning in. Subscribe to my channel. Psych, I'm just kidding. Actually, you can subscribe to my YouTube channel. That actually worked out. Okay, anyway, goodbye.